Hey everybody, good to see you today. We need to talk about how you can decide how much of each chemical to put into a chemical reaction. We're going to start with mole ratios. Now, mole ratios are a comparison of how much of this chemical it takes to react with how much of that chemical based on numbers of molecules rather than being based on mass. So let's start here with A. A talks about C4H10, which is butane, used in butane lighters, and oxygen, which is the gas in the air that supports burning. So we need to figure out the mole ratio for that. So we look in the balanced chemical equation. There's a 2 right there, so it's 2 moles of C4H10 for every 13 moles of O2. So 2 moles of C4H10 will react with 13 moles of O2. That's a mole ratio. You can use that in a big fraction later. Let's do B as well. So there's a 13 in front of O2, and there's an 8 in front of CO2. So we do 13 moles of O2 for every 8 moles of CO2. Now maybe you would need to flip that big fraction conversion if you had moles of O2 and you're trying to convert it, but that's your mole ratio. So let's take a look at our actual stoichiometry problem. So it says how many grams of KCl, that's the thing that we're looking for, and it's based on 1 gram of Cl2. And then it says excess K, that means that there's extra potassium. You won't have to worry about the amount of potassium. So we start with figuring out the molar masses of the chemicals that are going to be involved. Cl2. So Cl2, there's 2 times 35.45 grams. It's going to give me 70.90 grams for every 1 mole of Cl2. Now KCl is actually fake salt. So if somebody has a problem where they can't have enough or can't have too much sodium in their diet, they'll use KCl instead of NaCl. But add those up and you get 74.55 grams. Okay, we got the molar masses. Let's take a look at the first calculation, which is figuring out how many moles of Cl2 we have. So 1.00 grams of Cl2. How many moles is that? Well, I put grams of Cl2 on the bottom so those units can cancel. I use the molar mass of Cl2, that's 70.90 grams for every 1 mole. And when I do that calculation, I find out I have 0.0141 moles of Cl2. Now that I know how many moles of Cl2 I have, I can put that into the mole ratio. So we look at the balanced equation. There's an implied 1 in front of Cl2 and a 2 in front of KCl. So we write 0.0141 moles of Cl2. Moles of Cl2 goes on the bottom, so it'll cancel. And then moles of KCl goes on the top. Got 2 and 1. Moles of Cl2 cancels out, and we get 0.0282 moles of KCl. So we know that this reaction will make that many moles of KCl. The question is, what mass of KCl will it make? So that's 0.0282 moles of KCl. Let's use the molar mass. So that's 74.55 grams of KCl for every 1 mole of KCl. When you do that calculation, you're going to get a mass of 2.10 grams of KCl. So that is your answer. That's how much fake salt you would make from poisonous gas and explosive solid, just in case you ever want to do that reaction. Let's take a look forward at the rest of this worksheet. So this is just your standard grams to moles to moles to grams calculation, just like we've done several times in Kahoot or in that previous problem. Now this one's actually easier because it starts with moles and it ends with moles, so all you use is a mole ratio. One thing about 3, there's 2 problems, 1 and 2. Make sure you do both of those. Then looking down here at the bottom of 4, that's another grams to moles to grams problem. So make sure you contact me when you have questions. I would love to answer them. Make sure to come to Virtual Hive to get help, and I will talk to you in the next video.